When maintenance technicians at London Gatwick opened the flight data recorder from British Airways Flight 226 on the morning of March 18, 1988, they found something that should have been impossible. The aircraft had departed Singapore at 0847 hours local time on March 16th and landed at Gatwick at 1534 hours the same calendar date after a scheduled 13-hour flight. But the internal clock of the flight data recorder, synchronized to coordinated universal time and designed to maintain accuracy within milliseconds, showed a arrival timestamp of March 14, 1988 at EO 734 UTC. The aircraft had apparently landed 2 days and 8 hours before it departed. The Boeing 747-200 registered as Golf Bravo November Juliet Victor had been in service with British Airways since 1979. It was a reliable airframe with just over 42,000 flight hours logged across 9 years of operation. On the morning of March 16th, the aircraft sat at Gate F7 of Singapore Changi Airport's Terminal 1, being prepared for flight BA226 to London with a planned fuel stop in Bahrain. Captain Robert Hendricks, a senior pilot with 18,000 hours on type, completed his pre-flight briefing at 0615 hours. First Officer David Marsh and Flight Engineer Thomas Wells joined him in the cockpit at 0730 hours. The flight plan called for a cruise altitude of 37,000 feet, an initial heading of 290 degrees, and a total flight time of 6 hours, 40 minutes to Bahrain. Singapore's air traffic control cleared BA226 for pushback at EO 842 hours. The aircraft taxied to runway 02 center and received takeoff clearance at EO 846 hours. At rotation speed of 163 knots, Captain Hendricks pulled back on the yoke, and the 747 lifted smoothly into humid morning air. The tower controller confirmed wheels up at 0847 hours and handed the flight to Singapore departure. First Officer Marsh acknowledged the frequency change and checked in at 0848 hours, climbing through 4,000 feet. Everything proceeded exactly as it had on thousands of previous departures. At 0852 hours, BA226 leveled at its initial cleared altitude of flight level 150 and began a gradual turn to the northwest. The autopilot engaged normally. All 4 Rolls-Royce RB211 engines showed stable parameters. Fuel flow matched the flight plan calculations within acceptable margins. Flight Engineer Wells recorded standard readings in the technical log at the top of the hour. At 0907 hours, Singapore Control cleared the flight to climb to flight level 370 and proceed direct to waypoint Pybos on the airway to Colombo. Captain Hendricks acknowledged and initiated the climb. The aircraft passed through 28,000 feet at 0914 hours. At 0918 hours and 32 seconds, Singapore Control called BA226 with routine traffic information. First Officer Marsh keyed the radio to respond. But before he transmitted, every instrument on the flight deck flickered once, dimmed to half brightness for approximately 2 seconds, then returned to normal intensity. The flicker was simultaneous across all displays, analog gauges, and digital readouts. Captain Hendricks immediately scanned the overhead panel. No circuit breakers had tripped. No warning lights illuminated. The engine instruments showed no fluctuation in generator output. All 4 generators displayed normal voltage and amperage. Flight Engineer Wells checked the electrical system schematic, while First Officer Marsh completed the radio call to Singapore Control. The controller acknowledged the transmission with no indication of any interruption. Wells found nothing irregular in the electrical bus configuration. The battery switch remained in its normal position. Ground power had been disconnected 6 hours earlier during pre-flight. The auxiliary power unit was off. There was no identifiable source for a momentary power reduction affecting the entire aircraft simultaneously. Wells made a notation in his log. 09118Z, all instruments brief dim, cause unknown, no fault indications. The flight continued climbing. At 0923 hours, BA226 reached flight level 370 and the rate of climb decreased to 0. The aircraft leveled smoothly and accelerated to its cruise speed of Mach decimal 82. Singapore Control handed off the flight to Colombo Control at 0941 hours. First Officer Marsh checked in on the new frequency and received acknowledgement. The Indian Ocean stretched dark green below scattered cumulus clouds at 18,000 feet. Captain Hendricks disengaged the autopilot briefly to verify manual control response, then re-engaged it. The flight management system showed the aircraft precisely on course, passing through waypoint Pybos at 1008 hours, exactly on schedule. At 10:34 hours, flight engineer Wells stood up from his position to retrieve a checklist from the storage compartment behind the captain's seat. As he stood, he glanced at his wristwatch, a standard issue Breitling chronograph he had owned for 6 years and which he wound manually each morning. The watch showed 10:34 hours UTC. He looked at the cockpit chronometer mounted on the center instrument panel. It also showed 10:34 hours. He looked at the digital clock on the flight management computer display. It showed 10:32 hours. Wells stopped. He stared at the FMC display for several seconds, then checked his watch again. Still 10:34. He leaned over First Officer Marsh's shoulder to see the digital clock on the co-pilot's instrument panel. It showed 10:34 hours. Wells returned to his station and pulled out the technical log. He checked his previous entry, made at the top of the hour. He had recorded the time as 1000 hours UTC. He looked at the FMC display again. The clock now showed 10:32 hours and 15 seconds. He watched it for a full minute. The seconds incremented normally. At 10:33 and 15 seconds, he checked his wristwatch. It showed 10:35 and 15 seconds, a 2-minute discrepancy. Wells called this to Captain Hendricks' attention. Hendricks looked at his own watch, then at the FMC clock. He frowned. He pressed the button to cycle through the FMC display pages. The navigation page showed their position, ground speed, distance to the next waypoint. All normal. He returned to the primary display. The clock still showed 2 minutes slow. First Officer Marsh suggested the FMC clock might have reset during the electrical flicker an hour earlier, but Captain Hendricks pointed out that the FMC clock was independently powered and should not have been affected by a momentary voltage drop to the display systems. Even if it had been affected, it should have stopped or reset to 0, not simply begun running 2 minutes slow. Wells checked the circuit breaker panel again. Everything remained normal. Hendricks made the decision to continue the flight. A 2-minute clock discrepancy on the flight management computer was unusual, but not a safety issue. The primary flight instruments, navigation systems, and engine controls all functioned normally. He instructed Wells to make a detailed log entry and inform maintenance at Bahrain. At 11:47 hours UTC, BA-226 began its descent into Bahrain. Approach control vectored the aircraft for a straight-in approach to runway 30. The landing was smooth. The aircraft taxied to the international terminal and shut down at Gate 4 at 12:23 hours UTC. Total flight time from Singapore, 3 hours 36 minutes. Exactly as planned. Captain Hendricks remained in the cockpit while passengers deplaned. He pulled out the aircraft technical log and reviewed the entries. Wells had documented the instrument flicker and the FMC clock discrepancy. Hendricks added his own note and signed it. As he did, he noticed something. He flipped back through the previous pages of the log. The departure time from Singapore was recorded as EOS 847 UTC. He looked at his watch. It showed 1228 UTC. He looked at the FMC clock. It now showed 1226 UTC. Still 2 minutes slow. Exactly the same discrepancy as before. The refueling crew arrived. Hendricks stepped out of the cockpit to stretch his legs in the jetway. The Bahrain station engineer, a man named Malcolm Fraser, came aboard to review the technical log. Hendricks explained the electrical flicker and the clock issue. Fraser examined the FMC display, made several keystrokes to access diagnostic pages, then shook his head. He said he would run a full electrical system test during the turnaround, but that everything appeared functional. Fraser asked if there had been any other anomalies. Hendricks said no. Fraser signed off the log entries as reviewed and deplaned. BA-226 was scheduled to depart Bahrain at 14:30 UTC for the second leg to London. Boarding began at 13:45 hours. Captain Hendricks, First Officer Marsh, and Flight Engineer Wells returned to the cockpit at 14:02 hours. Fraser had left a note in the log stating that all electrical system tests returned normal results and that he could not identify a fault. He recommended monitoring the FMC clock and reporting any further discrepancies. Hendricks read the note and initialed it. At 14:28 hours, ground control cleared BA-226 to push back from Gate 4. The aircraft was fueled for 6 hours and 30 minutes of flight time plus required reserves. Takeoff from Bahrain was routine. The 747 lifted off runway 30 at 14:34 UTC and climbed northwest toward the Iraqi border. At 15:02 UTC, the flight leveled at flight level 370 and settled into cruise. The sun was high and the air smooth. Flight Engineer Wells monitored fuel consumption. The burn rate matched the flight plan within 50 pounds per hour. At 1600 UTC, Wells made his hourly log entry. As he wrote the time, he paused. He checked his wristwatch. 1600 UTC. He looked at the FMC clock. It showed 15:58 UTC. Still 2 minutes slow. He called it out. Captain Hendricks looked. He confirmed the discrepancy. Marsh checked the co-pilot's digital clock. It showed 1600 UTC. Only the FMC was off. Hendricks instructed Marsh to manually update the FMC clock. Marsh accessed the initialization page and entered the correct time. The FMC accepted the input. The clock now displayed 16:02 UTC in sync with their watches. Hendricks made a note in the log that the clock had been manually corrected at 16:02 UTC. Wells continued monitoring systems. Everything else remained normal. 20 minutes later, at 16:22 UTC, Wells glanced at the FMC clock again. It showed 16:20 UTC, 2 minutes slow. Again. Wells stared at it. He did not say anything immediately. He watched the seconds count. Normal rate. He waited another 5 minutes. At 16:27 UTC, he checked the FMC clock. It showed 16:25 UTC. He informed Captain Hendricks. Hendricks turned in his seat. He studied the FMC display. He asked Wells to confirm. Wells confirmed. The FMC clock was running 2 minutes slow despite having been manually corrected 20 minutes earlier. Hendricks exhaled slowly. This was not a reset. This was not a power interruption. The clock was consistently and repeatedly falling behind by exactly 2 minutes, as if it were running at a slightly slower rate than real time, but that was impossible. Quartz crystal oscillators used in avionics did not drift at measurable rates during operation. They either worked or they failed. Hendricks did not touch the clock again. He left it reading 2 minutes slow and decided to file a detailed report with British Airways Engineering upon arrival at Gatwick. The flight passed over Turkey, then Bulgaria, then Romania. At 18:04 UTC, BA-226 crossed into Hungarian airspace. Budapest control cleared the flight to descend to flight level 350. The descent was gradual. At 18:47 UTC, the aircraft entered Austrian airspace and Munich control cleared them further down to flight level 280. The FMC clock now showed 18:45 UTC. Wells confirmed the 2-minute lag was holding steady. At 19:23 UTC, Munich handed off the flight to Brussels control. First Officer Marsh checked in and received vectors for arrival into London. At 2018 UTC, Brussels handed BA-226 to London control. The aircraft was descending through flight level 180, 90 miles southeast of Gatwick. London Control issued a heading of 285 degrees and clearance to descend to 10,000 feet. Captain Hendricks acknowledged the auto-throttle reduced power. The rate of descent increased to 1,800 feet per minute. At 2034 UTC, London Control cleared BA 226 for the ILS approach to runway 26 left at Gatwick. Hendricks confirmed the clearance. The aircraft intercepted the localizer at 8,000 feet. The glide slope indicator centered. Hendricks disengaged the autopilot at 1,000 feet and flew the approach manually. The weather was clear. Visibility 10 miles. Wind 270 at 8 knots. The main landing gear touched down on runway 26 left at 2042 UTC. Hendricks deployed the thrust reversers. The aircraft decelerated smoothly and exited the runway at taxiway Bravo. Ground control directed BA 226 to gate 47 of the North Terminal. The aircraft came to a stop and Hendricks set the parking brake at 2047 UTC. Total flight time from Bahrain, 6 hours, 13 minutes. Wells shut down the engines in sequence. The APU started automatically. Hendricks completed the shutdown checklist and signed the technical log. As he did, he looked at the FMC clock one final time. It showed 2045 UTC, 2 minutes slow, exactly as it had been for the entire flight. British Airways Engineering dispatched a technician to gate 47 within 30 minutes. The technician, a senior avionics specialist named Colin Travers, came aboard and reviewed the log entries. He powered up the FMC using ground power and ran a series of diagnostic checks. He accessed the internal event log. He examined the clock calibration settings. He tested the crystal oscillator frequency. Everything returned nominal values. The clock was functioning within specification. Travers manually reset the FMC clock to the correct time and told Captain Hendricks that he would download the flight data recorder and investigate further. Hendricks thanked him and left the aircraft. The following morning, March 17th, Colin Travers inserted the flight data recorder from Golf Bravo, November Juliet Victor, into the ground-based readout station at British Airways Engineering Facility, adjacent to Gatwick's South Terminal. The recorder was a Fairchild Model F1000, standard equipment on all British Airways 747s. It recorded over 200 parameters, including time, position, altitude, airspeed, heading, control surface positions, and engine data. Travers initiated the data download at 0847 hours local time. The process took 43 minutes. At 0930 hours, the download completed. Travers opened the data file and began his review. He started with the departure from Singapore. The recorder showed pushback at 0842 UTC, takeoff at 0847 UTC, and climb to cruise altitude exactly as documented in the flight log. He advanced the timeline. At 0918 UTC, the electrical flicker occurred. The recorder showed a momentary voltage drop across multiple systems lasting 1.8 seconds. Travers noted this and continued. At 1034 UTC, when flight engineer Wells first noticed the FMC clock discrepancy, the recorder showed nothing unusual. All systems normal. Travers cross-referenced the recorder's internal time code against the event timeline. The time code was synchronized to UTC via the aircraft's GPS receiver and should have been accurate to within 10 milliseconds. Travers scrolled forward to the Bahrain landing. The recorder showed touchdown at 12:23 UTC, correct. He moved to the second leg. Takeoff from Bahrain at 14:34 UTC, correct. Cruise descent. Landing at Gatwick. The recorder showed touchdown on runway 26 left at 2042 UTC on March 16th. Travers paused. He looked at the data header. The date field read March 14th, 1988. He stared at the screen. He scrolled back to the beginning of the file. The initial date stamp, assigned when the recorder powered up at Singapore, read March 14th, 1988, 0032 UTC. Travers frowned. He checked the recorder's internal calendar. It was set to March 17th, 1988, today's date. He closed the data file and reopened it. The date field still read March 14th. He checked the file properties. The creation date was March 18th, 1988 at 8:47 hours, the date the recorder had been downloaded. But the internal date stamps embedded in the flight data read March 14th, 2 days earlier than the actual flight. Travers picked up his telephone and called the avionics department supervisor. By noon on March 18th, 3 senior engineers were examining the data. They confirmed that every timestamp in the flight data recorder, from engine start in Singapore to shutdown at Gatwick, was dated March 14th, 1988. But the flight had indisputably occurred on March 16th. The aircraft's journey log, signed by the captain and multiple ground personnel, showed March 16th. The ATC recordings from Singapore, Colombo, Bahrain, Budapest, Munich, Brussels, and London all showed March 16th. Passenger manifests, boarding records, and fueling receipts all showed March 16th. Only the flight data recorder showed March 14th. The lead engineer, a man named Peter Whitmore, proposed several explanations. The most obvious was a calendar chip failure in the recorder itself. But the F-1000 used a battery-backed real-time clock that maintained its calendar even when the aircraft was unpowered. The battery was tested. It was good. The calendar chip was tested. It functioned correctly. Whitmore proposed that the recorder had been removed from another aircraft that had flown on March 14th and accidentally installed in Golf Bravo November Juliet Victor. But maintenance records showed the recorder had been in continuous service on that airframe for 14 months. It had not been removed. Its serial number matched the aircraft's configuration log. Whitmore then suggested the date might have been corrupted during data download or storage. But the recorder used read-only memory with error correction codes. The data integrity check returned 0 errors. The date stamps were stored in a dedicated field of each data frame, written once per second throughout the flight. For the date to be wrong, every single frame would have had to be corrupted in the exact same way without triggering any error flags. The probability of this was effectively 0. On March 21st, British Airways forwarded the data recorder and a full incident report to the UK Civil Aviation Authority. The CAA assigned an investigator named Andrew Kellerman to the case. Kellerman was a former RAF pilot with a degree in electrical engineering and 12 years of experience investigating aircraft system anomalies. He reviewed the British Airways report, examined the recorder, and interviewed Captain Hendricks, First Officer Marsh, Flight Engineer Wells, and Colin Travers. Everyone's accounts were consistent. The flight occurred on March 16th. The recorder said March 14th. Kellerman ordered the recorder sent to the manufacturer, Fairchild Data Technologies, in New York for analysis. The recorder arrived on April 4th. Engineers at Fairchild subjected it to a comprehensive bench test. They powered it up, ran it for 72 continuous hours, and compared its internal clock to a cesium beam atomic standard. The clock drifted by less than 12 milliseconds over 3 days, well within specification. They examined the memory chips under microscope. No physical defects. They reviewed the firmware. No bugs. They confirmed the serial number and manufacturing date. The recorder had been built in February 1987 and delivered to British Airways in March. There was no defect. On May 9th, Fairchild returned the recorder to the CAA with a report stating that the unit was fully functional and that the date discrepancy could not be explained by any hardware or software fault. Kellerman read the report twice. He pulled out the original data file and examined it again. March 14th, 1988. He checked the metadata. He checked the checksums. Everything was intact. The recorder had faithfully documented a flight that took place on a date that did not match reality by exactly 48 hours and 8 minutes. Kellerman expanded his investigation. He requested the radar data from Singapore's Civil Aviation Authority. It arrived on May 18th. The radar showed BA-226 departing Singapore at 0847 UTC on March 16th, tracking northwest, and leaving Singaporean airspace at 0903 UTC. Kellerman requested the radar data from Colombo. It showed BA-226 entering Sri Lankan airspace at 0941 UTC on March 16th and passing through on course. He requested data from Bahrain, Turkey, Hungary, Austria, Belgium, and the UK. Every radar track showed March 16th. Every air traffic control voice recording showed March 16th. Every transponder interrogation showed March 16th. On June 2nd, Kellerman traveled to Gatwick and interviewed the refueling crew who had serviced BA-226 in Bahrain. They had no specific memory of the aircraft, but their fueling logs, time-stamped by the fuel truck's onboard computer, showed servicing at 1312 UTC on March 16, 1988. Kellerman obtained passenger statements through British Airways. 14 passengers remembered the date because they had connecting flights or important meetings in London scheduled for March 17th. All confirmed they had flown on March 16th. Kellerman returned to his office and wrote a preliminary report. He could not identify any plausible mechanism by which the flight data recorder's internal calendar could have reset itself to March 14th while continuing to operate normally in every other respect. He could not explain why the date error was exactly 2 days, not a random corruption. He could not explain the 2-minute FMC clock discrepancy, which had appeared suddenly, persisted consistently, and correlated with no identifiable system fault. He noted that the electrical flicker at 09 wait UTC remained unexplained. Generators had not fluctuated, no breakers had tripped. The event affected all displays simultaneously, but caused no warnings. On August 15, 1988, the UK Civil Aviation Authority closed the investigation with a finding of unexplained instrumentation anomaly, no safety impact. The report stated that the aircraft was airworthy, that all systems had been tested and found functional, and that the date discrepancy in the flight data recorder could not be reproduced or explained, but posed no operational risk. The report recommended continued monitoring of the aircraft's electrical and avionics systems. No further action was required. The file was archived. Golf Bravo, November. Juliet Victor returned to service on March 25, 1988, and flew without incident for another 9 years. The aircraft was retired in 1997 and broken up for parts. The flight data recorder was removed and sent to a British Airways storage facility in Wales, where it remained until 2003, when it was scrapped in accordance with standard parts lifecycle procedures. No further anomalies were ever recorded on that airframe. In September 1994, Andrew Kellerman gave a presentation on unsolved aviation instrumentation cases at a symposium in Montreal. He briefly described the BA-226 incident. After his talk, an engineer from Air France approached him. The engineer said that in June 1991, an Air France Airbus A340 flying from Paris to Buenos Aires had experienced an identical 2-minute clock discrepancy in its flight management system. The discrepancy appeared suddenly mid-flight, persisted for the duration of the flight, and could not be reproduced on the ground. The engineer said the incident was logged but never investigated because no other systems were affected. Kellerman asked if the flight data recorder had shown any date errors. The engineer said he did not know. The recorder had been routinely overwritten on subsequent flights. In October 1998, a retired Lufthansa flight engineer named Ernst Baumer contacted the UK CAA regarding the BA-226 case after reading about it in an aviation safety bulletin. Baumer stated that in April 1979, he had been the flight engineer on a Lufthansa Boeing 727 flying from Frankfurt to Tehran. Approximately 3 hours into the flight, all cockpit instruments had flickered briefly. Immediately afterward, the captain's wristwatch, the co-pilot's wristwatch, and the cockpit chronometer were all running slow by approximately 90 seconds compared to radio time checks from air traffic control. The discrepancy persisted for the remainder of the flight. Upon landing, ground engineers could find no explanation. Baumer's letter was filed with the BA-226 case documents, but prompted no further investigation. On June 14, 2001, a retired British Airways captain named Michael Stanhope gave an interview to an aviation history podcast. He mentioned that in 1982, he had flown a British Airways Boeing 747 from London to Singapore with a fuel stop in Bahrain. He stated that during the second leg of the flight, the aircraft's inertial navigation system had displayed a position error of approximately 18 nautical miles for a period of 20 minutes before correcting itself. Ground engineers found no fault. Stanhope said he had always wondered if the navigation system had been correct, and the aircraft had somehow displaced itself 18 miles without the crew noticing, then returned. He laughed when he said this. He called it an old pilot's ghost story. He did not mention a date. The official record of BA-226 consists of the CAA incident file, the British Airways maintenance logs, and the archived flight data recorder data. The data remains stored on a backup server at the UK CAA's Gatwick facility. The timestamp on every frame reads March 14, 1988. The flight occurred on March 16, 1988. No one disputes this. No explanation has been offered that accounts for both facts simultaneously. Captain Robert Hendricks retired from British Airways in 2003. In a 2009 interview, he was asked if he remembered the flight. He said he did. He said it was the only time in his career that he had encountered something he could not explain and could not forget. He said the 2-minute discrepancy bothered him more than the date error because he had watched it happen in real time. He said the clock fell behind, was corrected, then fell behind again at the same rate as if the aircraft were moving through time at a slightly different speed than the rest of the world. He said he knew how that sounded. He said he had no other way to describe it. If you follow aviation mysteries and unexplained incidents, subscribe for future investigations.